All right, class. This presentation is going to be on some of the draw commands. So some of the things like drawing a line, polyline, rectangle, arc, circle, donut, things like that. So some of the draw commands we have are polyline, polygon, rectangle, arc, circle, donut, spline, ellipse, ellipse arc, add selected, and then hatch pattern. A polyline is a connected sequence of line or arc segments that's created as a single object. So, just think if you were creating like a fence line around the house or something like that, you could use the polyline so that you could draw it. Wouldn't have to be in straight lines. You could do little segments, maybe go from fence post to fence post or something like that. So you'll use the p-line command, the polyline command to create an open or closed polyline for geometry that needs to have fixed width segments. So if you need to go, 10-foot segments or 2-foot segments, continuous paths for which you need to know the total length, contour lines for topographic maps, wiring diagrams and traces printed on circuit boards, and then process and piping diagrams. So all those would be some examples of where you can use polylines. Polylines can have a constant width, or they can have different starting and ending widths. So after you specify the first point of the polyline, you can use the width command, and you can see the arrow pointing down there. To specify the width of all subsequently created segments, you can then change the width value at any time, even as you create new segments. So if you needed something to go from, a really skinny line, a quarter of a millimeter, up to something that's 2 millimeters thick, you can do that with a polyline. So there would be an example of a printed circuit board on which the traces were created with wide polylines. The landing pads were created with the donut command, which we'll talk about here in just a minute. And polylines can have different starting and ending widths. So you can see the square or the rectangle one, and then one that has the ellipse here on the bottom. So the polyline command creates a 2D polyline, single object that is composed of line and arc segments. So if you look for this icon here, so to do this, you set the starting point for the polyline. A temporary plus-shaped marker will be displayed at the first point. Press enter starts a new polyline from the last endpoint, and then to go to the next point, you can create a straight or curved segment, just by clicking on your mouse. Close connects the first and last segments to create a closed polyline. So if you needed to close in, some type of shape. Half width specifies the width from the center of a wide segment to an edge, and then width specifies the width of the next segment. You can see there's half width, and this would be full width or width. Some things to keep in mind when defining half width or the width of a polyline. So the starting width becomes the default ending width, which means if you wanted a different, if you didn't want it to be the same size as the starting, you'd have to specify that. The ending width becomes the uniform width for all subsequent segments until you change the width again. And the starting and ending points of wide line segments are at the center line of the segment. Typically, the intersections of adjacent wide polyline segments are beveled, so you can see here. No beveling is performed for non-tangent arc segments, acute angles, or when a dot dash line type is used. The polygon command, so this will create an equilateral closed polyline or polygon. So find the pentagram here. So you specify the number of sides on a polygon. So if you wanted a triangle, a square, a hexagon, an octagon, whatever you wanted, you could do that. And then you'll determine whether it's inscribed or circumscribed. So inscribed would be inside the circle, and then circumscribed, you can see, goes around the outside edge of the circle. These would be your two following prompts. Then you can specify the number of sides, so you can go from 3 to 1024. The center of the polygon specifies the location where the center will be, and whether the new object is inscribed or circumscribed. So if it's inscribed in the circle, it specifies the radius of the circle on which all vertices on the polygon lie. So you can see the vertices here, here, here are all inside the circle. Specifying the radius with your pointing device determines the rotation and size of the polygon. Specifying the radius with a value draws the bottom edge of the polygon at the current snap rotation angle. Circumscribed about the circle, so this specifies the distance from the center of the polygon to the midpoints of the edges. So you can see the circle is tangent to the midpoints here. Specifying the radius with your pointing device determines the rotation and size of the polygon. So just, where you have your arrow or your cursor, and then how far you drag it out is just going to determine the size and how it's oriented. Specifying the radius with a value draws the bottom edge of the polygon at the current snap rotation angle. Edge, so this defines a polygon specifying the endpoints from the first edge. So if you go from 1 to 2, it'll get that size. Rectangle, so if you find the rectangle command, you can specify the first corner of the rectangle, then the other corner of the rectangle, and you'll have a rectangle in place. It's just that simple. You can also do it by length and width. Specify the first corner of the rectangle, enter D for your dimensions, so you enter the length of it, whether it's 2 inches or 1 inch, whatever it needs to be, and then the width, same thing, 1 inch or a half inch, whatever you have, and specify your other corner. By area, so you can draw one by area if you needed to. So when you go to your rectangle command, you'll enter A for area, enter the area. You can enter L for the length, and then the width will be calculated based on whatever area you put in, or you can do that with the width, and then the length will be calculated. With rotation, so you can enter R for rotation with the rectangle command, and then you'll enter P to pick 2 points for the angle of rotation if you don't want to specify it with a cursor. So the arc command creates an arc, so if you find this symbol on AutoCAD, so to create an arc, you can specify combinations of center, endpoint, start point, radius, angle, chord length, and direction values. Arcs are drawn in a counterclockwise direction by default. You want to hold down the control key as you drag to draw in a clockwise direction. So if the arc's not going in the direction you want, you can hold down the control key and it will flip it. So the following options are available. So you'll go from your start point, then you'll specify the second point, and then specify the third point for this particular way to do it. So 3 points. So you go by center. So your first point will be point 1 here, then point 2 will be your center point, and then you pick the other end of the arc with point 3. The circle command creates a circle, obviously. So usually for a circle, you'll do it from a center point. So you click where you want the center of the circle, and then you can drag your cursor out a specified distance to make the size of the circle, or type in a distance if you know what size you want the radius to be. So if it's 1 inch, 2 inch, 20 millimeters, whatever it is, you can specify that. The diameter, so you can enter a diameter value. You can see there they have 0.750. You can do a circle with 3 points. So if you go from here, you'll pick point 1, then you'll go to point 2 and go to point 3. That's helpful if you want to be touching some other parts, or if you want to be tangent to other parts. Tangent, tangent, tangent will create a circle that's tangent to 3 objects. 2 points creates a circle based on the 2 endpoints of the diameter, and you can see where they have that there. And then tangent, tangent, and radius creates a circle with a specified radius and one that's tangent to 2 objects. A donut creates a filled circle or a wide ring, so basically just a donut. Donut consists of 2 arc polylines that are joined end to end to create a circular shape. The width of the polylines is determined by the specified inside and outside diameters. If you specify an inside diameter of 0, the donut is a filled circle. So when you do the donut command, the following prompts are displayed. So the inside diameter, so what size would you want the inside diameter, and then the outside diameter for specifying the outside dimension. The center of the donut specifies the location of the donut based on its center point. So wherever you pick that center point to go, the donut will be drawn each time you push your mouse button. Spline, So this creates a smooth curve that passes through or near a set of fit points. So when they say fit points, these may be points that you've already picked on your drawing. They'll be specified areas or just some locations that you deem to be important. So if you find the spline command, it creates curves called non-uniform rational B-splines, or NURBs, referred to as splines for simplicity. They are defined with either with fit points or with control vertices. By default, fit points coincide with the spline, while control vertices define a control frame. Control frames provide a convenient method to shape the spline. And as you get to experiment with it, you'll see the differences on the two ways to do it. An ellipse creates an ellipse or an elliptical arc. So remember, we talked about that before we started drawing on AutoCAD, what an ellipse is. The first 2 points of the ellipse determine the location and length of the first axis or the major axis. The third points determine the distance between the center of the ellipse and the end point of the second axis, or your minor axis. Ellipse arc, so this creates an elliptical arc. The angle of the first axis determines the angle of the elliptical arc. The first axis can define either the major or the minor axis depending on its size. The first 2 points of the elliptical arc determine the location and length of the first axis. The third point determines the distance between the center of the elliptical arc and the end point of the second axis. So, on this one would be your minor axis. And then the fourth and fifth points would be your start and end angles. You can customize many aspects of how objects are selected in order to speed up your work. So you can right-click in the drawing area and choose options. On the selection tab, you can choose the settings that you want. So whether objects to be selected are previewed, whether selected objects are highlighted, whether the interactive outcome or active commands are previewed, how you define selection areas, and then whether you can select objects before you issue a command. And hatch. So when we actually get into filling in parts or doing some section drawings, we'll use some hatching. So if you go to the Home tab and Draw panel, you can look for hatch. And on the Properties panel, hatch, you'll see the hatch you want to use. One here, they give an example, is ANSI 31, so be a type of steel. And then on the Boundaries panel, you can click Pick Points. And then you'll click inside a circle or a rectangle or a triangle. Any object that's closed in, and what that'll do is it'll create a pattern inside that shows that's like a solid entity or a specified type of material like concrete or sand or steel or whatever the material may be. So here's some videos from SDC for you to watch. So you'll click on those, and those will give you some further instruction. And I'll have the homework up shortly. All right, let me know if you have any questions, and I hope everyone has a great day.